Hey guys, it's Mr. Walker here again, back at the home studio again for another no frills kind of math lesson, and I apologize for that. But the reason being is that there's so much content, so much good information to get through that we don't have time for any fun stuff. But I do have unit cubes, so I mean that's exciting, right? Okay, maybe not really, but I'm also standing up, so like that's cool because I'm like ready to work and ready to go. All right, well, it was worth a try anyway. But honestly, this lesson here is one of my favorite lessons because we're talking about multiplication comparison problems. And the reason I like it so much is that I'm kind of a comic book nerd, right? And one of my favorite superheroes is Batman. Okay, everybody loves Batman. Most people love Batman except for maybe this guy. But anyway, one of my favorite Batman villains besides that guy is also the Riddler, right? He told a lot of different riddles and kind of got Batman thinking on his feet, and it was kind of interesting. And the way I look at these multiplication comparison problems that we're going to be working with is they're kind of like riddles, okay? They're giving us like just enough information that we have to do some thinking and have to do some configuring using multiplication to kind of figure out what it is that they're talking about. So it's kind of exciting in that way, kind of different. So hopefully you guys will feel the same way too as we go through the lesson. So a couple things that you're going to need. Again, if you have that graph paper, if you have some sort of graph paper, that's good. If you have your personal whiteboard, something to write on, something to write with, that would be awesome. And if you do have any tiles, now we do have some of these available at eSchool. But anything really that's the same shape and the same size. So like this is a square, right? It's at 1 unit. It's got the same measurement on the length as it does in the width. So if you have something like whether it's a Lego or blocks or anything like that that are the same length and same width, you can use those as well. Or you could just draw them in or just follow along with me in the video. Anyways, cool. These aren't like essential, but they do help in some situations. So if you have those things together, you want to gather them up. And then when you're ready to go, just click continue and we'll start rocking and rolling. All right, so we're going to start with our first Riddler-esque kind of math riddle here. And this one says that a rectangle is 1 inch wide and it is 3 times as long as it is wide. And we're going to use these square tiles to help us figure out the length of this rectangle. So we know that it's 1 inch wide. We don't know the length of it, but we know that it is 3 times as long as it is wide, okay? So what I'm going to do is I'm going to start with my unit cube, right? And I know that it's 1 inch wide, okay? And this, my unit cube is 1 inch wide. So I'm just going to label this as, if I can get my marker to work, label this as 1 inch. Okay, easy enough. And according to the riddle, to the problem that we have, it's 3 times as long as it is wide. So if it's 1 inch wide, I know it's going to be 3 times as long. So what I'm going to do is I'm going to put out 3 tiles now, okay, because it is 3 times as long as it is wide. So when I lay out these 3 tiles now, I can count this up as 1, 2, 3. So I know that it's going to be 3 inches wide. Okay? I could think about it as 1, and I know it's 3 times as long, so 1 times 3 would give me 3, so that would, again, give me the total. I could just kind of lay it out here with the unit cubes, with the unit tiles, whatever you want to call them, to help me out. Now let's throw an extra layer onto this. Let's say that we wanted to make this 2 times as long as it is now. 2 times as long as it is now. How could we do that? Well, I have my one rectangle here. That's 3 by 1 inches. If I was going to double that, I could just make another one that's the same size, right? So now I have doubled it. So what is our new length and width? Our width is going to stay the same, but our length is now 6, right? So now we have 6 going across here. Perfect. Okay, not too bad, right? What if I wanted a rectangle that was 3 times as long as what we originally started with? 3 times as long. Again, this would be 2 times as long, and then I could get 3 more cubes. I'm sorry, then I could get 3 more tiles. I'll lay them out here, and holy cow, I can't even fit it on my screen here. It's going off my board and everything, but now we would have 9, right? So our original one was 3. If we want 3 times as long, it would be all the way out to 9. Okay, starting to get the idea here of when we're talking about however many times as much, we can just double it or triple it or whatever that I need to. Start with my original, which was 3. If I wanted to find 3 times the length, I would multiply it by 3, and 3 times 3 equals 9. To find twice the length, 2 times the length, we did 3 times 2, which again gave us 6, and we're good to go there. So you can see how we can use these models to help us out, but we can also do the math using different strategies, different formulas, different equations to help us out. All right, let's step this up a little bit, right? Go big or go home, as they say. What if I had a rectangle, or a square in this case, I guess you could say, that was 3 by 3, right? So 3 for my width, 3 for my length. And what if I said that this, I wanted to find a rectangle that was 3 times the length of this rectangle? What could I do? Again, it would be 3 times 3, right? So if I built 3 more of these out, it would look like this. So I did my 3 times 3, 1, 2, 3, and that would give me a total of 9. So just because my width got bigger doesn't mean I'm going to do something different to the length necessarily, but it does change my overall shape, right? It's going to be a much bigger rectangle now. It's going to take up a lot more space. My area is going to increase, all because I had to increase, all because I had to multiply by 9 to get out there. So we can either visually represent this, manually represent this with some shapes, but we could also think about it as if I started with my original rectangle, which was 3, had a length of 3, and I wanted to find 3 times the length. I would just multiply that by 3, which would give me 9. Okay? With me so far? All right, awesome. All right, I'm going to step away from the physical models for a second and work on just drawing, okay? So again, if you have something to write on, something to write with, you can follow along with me. And what I'm going to take a look at now is, I'm going to take a look at another kind of riddle, right?
Riddle me this, riddle me that.
And we're going to solve it just kind of drawing it out, okay? So this riddle says, all right, so this riddle says, a rectangle is 2 meters wide. It is 3 times as long as it is wide. Draw to find its length. Okay, so you know, obviously with this riddle here, the fate of Gotham doesn't fall in our hands here, but it is kind of interesting to try to figure this out. Like, what size rectangle is this? Okay, so we know that it's 2 meters wide and it's 3 times as long as it is wide. So I'm going to start by drawing its width here. So my width would be 2 meters. All right. And then my length is going to be 3 times as long as it is wide. So I'm going to start by drawing like one length that is 2 meters wide, and I want to think of that. I'm going to have that 3 times, right? Because it's 3 times as much. So I'm going to have one of those. All right. I'm just going to draw like some dotted lines here, and I'm going to have 2 of those. Another 2 meters. Okay, and then one more. That would give me 3 times my original, right? And I can kind of close off this shape here. So if we think about it as 2 meters wide is my width, my length is 3 times that. So 2 meters once, 2 meters twice, 2 meters 3 times. So what is going to be the total length of my rectangle? You're right, it's going to be 6. 2 plus 2 plus 2 would give me 6. 6 meters total. Or you could think of it as 3 times 2, right? 3 times 2, which is my width, would give me 6 meters. Perfect. So knowing that, I could draw a rectangle now that is 2 meters by 6 meters. Okay? And knowing that about this rectangle, what would the perimeter of this rectangle be? If you need to go back and refer to your chart from the previous lesson that we created with the different formulas for finding perimeter, go ahead and do that. But tell me, what would the perimeter be? All right, so to find my perimeter, I'm going to do 2 plus 2 plus 6 plus 6. You could use different formulas if you'd like doing 2 times the length, which is 6, plus the width, which is 2. Or you could do 2 times 6 plus 2 times 2. It's totally up to you on whatever formula you want to use. But regardless of what formula I use, I'm going to get the answer of 16. And it's going to be 16 meters. And there we go. So easy enough. So even though we got this crazy kind of riddle thrown at us with a rectangle that's 2 meters wide and 3 times as long as it is wide, we were still able to figure it out using drawings and using different formulas to be able to figure out what the length was. And then we even took it a step further by finding the perimeter. Could we find the area as well? Sure, it's length times width, right? So 2 times 6 would give me 12. And since it's area and we multiplied, it's going to be 12 square meters. Okay? So we could say our perimeter equals 16 meters. And our area would equal 12 square meters. Awesome. Let's see if the Riddler has another one for us.
Riddle me this, riddle me that.
Alright, so here's the next riddle that the Riddler threw at us, right? And boy, is it a doozy. Okay, so starting here, it says Poison Ivy painted a mural with an area of 18 square meters, okay, which I didn't realize she was a painter, but evidently she is, and a length of 6 meters. So what is the width of her mural? Okay, so right now we have like a missing length, or I'm sorry, a missing width, missing dimension problem to start. But then it kind of goes on here and it says her next mural will be the same length as the first one, but 4 times as wide. What is the perimeter of her next mural? So we got like a two-parter going on here. So the first thing I'm going to want to do is I'm going to read this again and I'm going to break down some of the important information that I think we're going to need. So first off, it says that she painted a mural with an area, okay, area is a good vocabulary term that we know, of 18 square meters. So I'm guessing that's probably going to come in handy somewhere. 18 square meters and a length of 6 meters. Another good measurement here. And length, that's another vocabulary word that we know. And they're asking us what is the width of her mural. So let's start there before we even dive into the second part of this question. Let's just start there and see what we can figure out. So we know that she has a mural and it has an area of 18 square meters and a length of 6, and we don't know what the width is. So I'm going to start by drawing something that's 6 for the length. So say 6 meters. I don't know what the width is, so I'm just going to put a W for width because I don't know what it is. And I'm going to assume it's rectangular in shape, or at least somewhat rectangular. And we do know that it is 18 square meters. All right, perfect. So if that's our area, and we know to find the area you have to do length times width, so 6 times what will give us 18? 6 times what will give us 18? So again, our area is length times width. We have a length of 6, so 6 times what will give us the area of 18? Well, I know that 6 times 3 will give us 18. So that must mean that my width is 3 meters. All right, cool. So we have the width figured out already. We got the first part of our problem. But now it says her next mural will be the same length as the first, so it's going to stay 6 meters, but it's going to be 4 times as wide. Interesting, interesting, right? Okay, so what's the perimeter of her next mural? So there's a couple things going on here. So we know that her next mural is going to be the same length, but it's going to be 4 times as wide. So if I kept my length of 6 here, 6 meters, and we know that the first one is 3 meters wide, right? So we can match that up. I'm just going to draw a dotted line across here. And she's saying that her next mural is going to be 4 times as wide. So I know I'm going to have to take that 3. I'm going to have to do it 4 times, right? So I have 1. Here's 2. Here's 3. And here's 4. And each one of these is 3 meters. So what would the new width of the second mural be? What would the width of the second mural add up to be? Perfect. Well, 3 plus 3 plus 3 plus 3, or 3 times 4, would give us 12. 12 meters. Wow. Okay, that's going to be a pretty big mural, right? Hopefully she's painting like Batman or something, right? It'd be kind of cool. All right, so we know that now. We know that our width is going to be 12. Our length is going to be 6 because our length stayed the same. But our final question here is, what is the perimeter of her next mural? So how would I find the perimeter of this? Awesome. Again, there's a lot of different ways I could find it, right? So I could do 2 times the length plus the width, which would be 2 times the length, which is 6, plus the width, which is 12. And that would give us 36 meters. I could have done 6 plus 6 plus 12 plus 12, which would have given me, well, 6 plus 6 is 12, plus 12 is 24, plus 12 is 36. Again, would have gotten the same answer there. Or I could have done 2 times our length, which is 6, plus 2 times our width, which is 12. 2 times 6 is 12. 2 times 12 is 24. 12 plus 24 would give me 36. So again, I could have used any of those formulas to help me get my perimeter. I would have gotten the same answer on all of them. Hopefully you guys did something similar and got the same answer. Awesome. So the Riddler, he's a tricky guy, but I think we're doing okay so far with what he has going on, okay? So hopefully this is all starting to make sense, starting to come together a little bit for you guys. We could see how we can kind of solve these math riddles, knowing like finding 3 times as much as something, or 2 times as much, or 4 times as much in relation to the area models and the area and perimeter that we're dealing with. So if you guys have any questions, comments, or concerns, as always, reach out to me, let me know, reach out to your learning guide, reach out to a teacher, whoever, self-advocate, right? But you're going to practice this a little bit on your own, have some fun solving these math riddles, and as always, please let me know if you need anything else. Alright guys, thanks for watching.